Right. Anyone got me an answer for the mean value?
I got 13 for that, Mike.
13 for the mean. I don't know what's happened there then, Lewis.
Five.
Five.
Yeah,
Five.
I got
Five.
Five.
Oh dear.
We shan't write them all out, but the sum of x is equal to 65 when you add them all up. So that x bar is 65 and there's 13 in the set, which is, as you rightly say, 5. Yeah. When you write them all out in order to find the median, the middle number median value is 4. And the mode is the most frequently occurring, which is 3. Yeah. So what do you reckon you've done, Lewis?
I don't know. No, I think I don't know. I wrote it down wrong. I did put 5 in there. I put 65 divided by 5 somehow. I don't know. It's just me being stupid.
Okay. Well, you know, we all make mistakes, don't we? All right. Have a go then at that one. All right.
Mike, what's that line there between? Is that 54 and then 40, or is that a little?
That's 54.4. I don't know why that's on there, but that's 54.4. That's probably where I had the cursor when I took the screenshot, I reckon. Okay, so that's mean, median, and mode of ungrouped data. What we're going to do now is move on to mean, median, mode for group data. Okay, so the mean value for a set of group data is found by determining the sum of the frequency times class midpoint values and dividing that by the sum of the frequencies. So you take the midpoint values of each class, that'll be, so these become, let's just change the color on my pen. The values of X become midpoints of each class. Yeah, and this is the frequency of that class. How many times an item falls in that band. So that's like bands of values, they're called classes, and X value for that class is the midpoint value. And then you multiply those two together, add them all up, and divide by the total number of items. So you add all the frequencies up. And that most succinctly described by the sum of F times X over the sum of F. And that will become much clearer when we have a look at the proper example. Okay. So let's have a look at one. So frequency distribution for the value of resistors in ohms is So there's 48 resistors, and that's each of them. We've got the bottom of the class and top of the class. So we set the class boundaries top and bottom. So the first class is from 20.5 to 20.9, and 21.0 to 21.4. So each one is covering half of a digit. Yeah. And then in each of those classes, we've got the frequency. So first thing we need to do is find the midpoint values of each of these classes. What would be the easiest way to find the midpoint value?
Top class minus bottom class? Or no, plus them divided by 2, sorry.
Yes, to bottom of class plus top over 2. Yeah. So in this case, we do 20.5 plus 20.9 and divide that by 2. 20.7. Yeah. And then what we do is we multiply that class midpoint value by the class frequency. To get 428.49. Okay. So if you'd like to do the rest of those, and then we'll look at how we calculate the mean.
What are you doing? What are you multiplying it by?
We're multiplying this frequency value, F,
Yeah.
by that midpoint value.
That's wrong, Mike.
I was going to say, because I don't get that.
I get
Oh,
60.
hang on.
I get 62.1.
Yeah, I'll multiply the blinking. Oh, you pushed the buttons on my calculator wrong, I reckon. Absolutely stupid answer. 62.1. Yeah. All right. So rest of those, please. Right, how are we doing? Class midpoints. There's your class midpoints you should have. And there's your frequencies. And down the bottom, this is the sum of frequencies. So that's all these ones added together. Sum of f times x, sorry. And that's the sum of f. And this one is the sum of f times x. And then from that, we can get the mean as sum of fx over sum of f, 1052.1 over 48. I'll make that 21.92. You get that? Anyone get that?
Is the 21.92 the mode?
No, that's the mean.
Mean.
Yeah. So x bar, Kirsty, means the mean, the mean of. We're not doing the median and mode of group data. Just the mean. Anyone have any trouble with that at all?
No, that's worked all right. That's worked good.
Yeah, anyone else?
No, that's all good.
All good here.
No, yeah, all good.
All good, all good, right. So we're going to look at now is something called standard deviation. And this all looks a little complicated to start with, but the example will hopefully make it clearer. Standard deviation of ungrouped discrete data. So a standard deviation of a set of data gives an indication of the amount of dispersion of members from the measure of central tendency. So that could be the mean, median, or mode as a measure of central tendency. And what standard deviation does is give you like an average spread of values away from that mean or that central tendency. Value is the root of the mean square value of the data, and we obtain it as follows. So we determine a suitable measure of central tendency. We're just going to be using the mean, but you could choose the median or the mode. We calculate the deviation of each set member from the mean. So we do that by taking that set member, so for example, x1, and subtracting the mean away from it. So we do that for all the values in the set. And then we determine the squares of these deviations. The reason for doing that is we're interested, if here's the mean value, we're interested in how far away that x1 is from the mean value. We're not interested in whether that's lower than or higher than. So by squaring these values, we remove any negative values. Okay, so that's effectively what that does. So we find the the deviation. We square the deviation. Then we add all of those squares together to get a total of all the squares, and divide by the number of values in the set here. So a sum of squares, divide it by the number of values, and then take the square root of the result. So this bit here gives you the mean square, and then we take the square root of that to get the mean. Okay, that's quite a lot to take in. All right, then that can be written quite succinctly. That's the process to go through. Measure central tendency, like I say, we're going to use the mean. Calculate the deviations from that, square them, add them all together, divide by the number of values in the set, and take the square root. Okay. So written succinctly in math terminology, the standard deviation is indicated by the Greek letter sigma. It can be written mathematically as the square root of, and then we take, this is the sum of all the squares, and this is how many numbers there are in the set. Remember, at the moment we're talking about discrete data, ungrouped. So where X is a member of the set, X bar is the mean value of the set or other measure of central tendency, median or mode, and N is the number of members in the set. Okay. Hopefully on the next slide, there's an example that will help make that clearer. Okay, so determine the standard deviation.
Sorry, Mike, can you back one?
Yeah, can do, yeah, sorry. Yeah, way go.
Lovely job, thank you.
Okay, so just going to look ahead a bit for a minute. Yes, okay. We're going to look at this example. All right. So we're going to do this step by step. The first thing we need to do is find the mean. So we know that X bar is equal to all the values added together. So that's 5 plus 6 plus 8 plus 4 plus 10 plus 3. And divide that by the number in the set, which is 6. We get 6, according to Mr. Bird. Okay. Then what we need to do is find the standard deviation. So the first thing we need to do is find what we really want is a table. So X minus X bar for each value. So for the first one in the set, we got -1 because we got 5 minus 6. Yeah, 6 minus 6 is nothing. 8 minus 6 is 2. 4 minus 6 is -2. 10 minus 6 is 4. And 3 minus 6 is -3. Yep. Then we need to square those. So -1 squared is...
Sorry, can you just repeat the first bit?
Which bit? This up the top here?
No, just where the -2 is 0 to
Yeah.
-2.
What we're doing is finding the difference between each of these values and the mean. So going back to here.
Oh, okay. So first number was -1, not -2.
Yes.
Okay.
Yeah. All right. Does that look like a 2? Yeah, it does a bit, doesn't it? So that's -1. All right. So -1 squared is 1. That one has to be 0. 2 squared is 4. -2 squared is 4. 4 squared is 16. And -3 squared is 9. Yep. Okay. And then we need to sum all of those. Let's just sum of x minus, so we sum all these up, 5, 9, 25, 34. Yep. All following so far? And then we know now that the how many we got in the set is 6. So the standard deviation sigma is equal to square root of sum of x minus x bar squared over n. So that's square root of 34 over 6 which is square root of 5.6 equals 2.38. Yep. We all follow that in essence. We find an arithmetic mean, which you learned to do in the early part of the session. It's done here. Add all the values up on the top. Divide by the number of values in the set to give us the arithmetic mean x bar. Just going to cross that out. That doesn't mean anything. We find the difference between each of these values and the mean. So we subtract each x value from the x bar value. That's this column. And then we square each of these values to give us this column. And that has the effect of removing any negative signs. We add those up. We divide that by the number in the set and take the square root. And we end up with the standard deviation. So what that's saying is the average distance of each value from the mean is 2.38 in that set. Okay? Everybody okay with that?
Yep.
Yeah, good. So that's for ungrouped data. We can also calculate the standard deviation of group data. So the way we do that is with this formula here. So we've got the sum of, and then that's, if you look there, you've again got this x minus x bar squared, but you're multiplying that value by the frequency in each of the groups. Yeah, and then taking the sum of all of those values and dividing it by the sum of all the frequencies, and lastly taking the square root of the answer. Okay, so if we look back at the previous formula, that's just got x minus x bar squared on the top line, sum of. The formula for group data simply multiplies the squared values by the frequency of the set as well, and we divide by the sum of all the frequencies. And again, that is probably best served by looking at a particular example. So we'll do that now. Okay.
Sorry, can I just get the formula down quickly?
Yeah, of course you can. And in a spreadsheet answer, as long as you show me the formulas that you've used, the method to do that. Okay, so we got a problem. Frequency, this is the resistor problem. Values of in ohms of 48 resistors is as shown. Okay, so this is the problem we looked at earlier, I believe. So we've got bottom of class and top of class, and then we calculate the midpoints, which we did. Got the class frequency and frequency times the midpoints. Yeah, and then we divided this total by the total of the frequency and got a mean of 21.919. Yeah. So what we now need to do is find all the x minus x bar values to go in this column here. So the x value, remember, is the mid-class point, and the x bar is this mean value here. So the first one is 20.7, take away the 21.919 equals a minus 1.219 that's already shown. Yep. What we then need to do is square that value to get the 1.485 here. Yeah. And then multiply that value by the class frequency, which is in this column here. So we're going to multiply that 1.485 by 3. 4.457. Probably because I used a different number of digits. Anyway, that's near enough. Oh, hang on. To give us that value. Okay. So when you've done that, then you can add up the columns here. This one. To give us that line. We sum the frequency over here, take the square root, and find the standard deviation. So have a go now to see if you can fill those columns in. Find these two, find this top line, and we've already got 48 on the bottom, and find the standard deviation of that group data.
I've got 0.645.
Me too. Ah, yes.
That's the first column you were asked for, Lewis. Yeah. And that's the second column.
Can you just tell me what the E stands for again in the formula? I didn't get that last time.
Well, the Greek letter sigma,
Yeah.
that's the sum of. So what that means is.
Hello and welcome to the calculator guide video on
If you've used Excel spreadsheets at all, you'll know that the basic add all the columns up as the sum, and you'll see that symbol on there.
essentially the question is to change from degrees to radians, particularly with trigonometric functions, sine, cosine. We're going to change the calculator from degrees to radians. We need to access the setup menu. Press Shift and Mode is the setup. We're interested in the second line.
So they're all your squared values. Again, you might be slightly different if you've rounded slightly differently to me, but as long as you're quite close. So we then have, that gives us the sum of all the values, the squared values, multiplied by the frequency. We then put that into this formula down here, and we end up with a standard deviation of 0.645 according to data that I've used.
How have we got the same answer, but my total in my last column comes to 19.944?
I think what that'll be is I've used a spreadsheet for this.
Okay.
Right, and what I've done is I've probably not rounded, but I've just displayed 3 decimal places.
Okay.
But the spreadsheet's still using all the decimal places.
Oh, that's fine. So I was thinking that's a bit,
Right?
yeah, if I was out.
Which is a bit strange, but that
Yeah.
I've produced the answer using a spreadsheet, which I'm going to show you in a minute anyway.
Okay.
And although I've constrained those to 3 decimal places, I think the spreadsheet still uses the full value unless you physically round it using a function. Okay, is everyone all right with that? Did you get that answer? Don't appear to have any dissenting voices.
Yeah, I'm back again.
What, you been away again, Fred?
Yeah, it crashed and I did an update on the Zoom and now it seems to be working a bit better.
Okay, Fred. Well, hopefully you can stay with us best you can. I am recording as best as I can, so you'll be able to look back.
All right, yeah.
Yeah. Is this likely to keep happening every week? Is it or something?
No, it's not likely to. Yeah, it should work. It's worked fine.